Hey guys, this is Akansha and welcome to Tech Masterni. In our previous session, I have covered the photolithography process and various pattern generation technique. There we have seen that how mask is used for creating a window and how mask is responsible for the bad resolution. Okay, so now we will see how we can remove the mask from our procedure and create a high resolution window. Now we have one particular process which is called electron beam lithography. This is a serial process. Now let us understand here. In a photolithography process, this is my P substrate over which I have my SiO2 over which I have placed my photoresist. So this is my photoresist. And there I have my mask, and when the light fall on upon it, it will create window over this particular region. So the window will create simultaneously in all the region. So this is called parallel process. Now in the electron beam lithography, I have a serial process. So in this serial process, let's suppose this is my top view of wafer. And when the electron beam fall upon the resist, now let us suppose here the electron beam fall upon my resist. Now it has to move, it will remove this particular region of resist. Now it will fall upon this region, so it will remove this region of resist. Now it will reach on this region, so it will remove this region. So in this way, I need to move my electron beam in whole surface to remove the photoresist of this surface. So it is a one by one procedure of removing photoresist. So it is a serial process. I hope you have understood this point. Now let us see the whole picture here. So this is my electron beam lithography setup. This is my vacuum chamber under which I have my table upon which I have placed my silicon wafer. So this silicon wafer is P substrate over which I have my SiO2 layer and over which I have placed my resist. Here we call it as a resist because it is not a photo uh, light dependent procedure. It is just a electron beam procedure, so we call it as a resist only. So this setup I have placed here. Okay, now let us see the other parts. So to move this particular wafer left and right, I have my table position circuit. So this circuit will control by this computer controller, and on the other hand I have my deflecting coil. So these deflecting coil will move my electron beam left to right so that it will fall on the perfect place of the surface of the silicon wafer. Now next I have my beam blanking circuit. So beam blanking, as the name suggested, it is used for blanking the beam. Now let us see here. So this is the top view of my wafer. So this is my photoresist. So here this is my photoresist and I want to open this region of my window. So first I will fall my light on this region, sorry, electron beam on this region. Now I will move this here and this is a serial movement of the electron beam. Now I want to go back to this particular region. To go back this particular region, I need to stop beam for very small time so that the beam will reach here and it will again go to this direction. For this purpose, I will use my beam blanking circuit. So beam blanking circuit will blank the beam, will remove the beam for the time where I want to remove this beam. So now let's suppose I have reached to this point or I want to reach to this point. So I will remove my beam and I will place my beam here, and now I will again create my photoresist. So in this way I have created my whole region. So I hope you have understood the point of electron beam. Now let us move to the next point. In this process, we do not need any mask. So you can see we directly fall beam upon the surface and remove the photoresist. We do not need any mask because whenever I want to open the window, I will just fall my beam upon that region. Okay, so as we do not use photo mask, so it has a high resolution. So the resolution which will deteriorate in our previous process is due to the mask. So now I have a good resolution because I will not use mask here. So this is all about the electron beam lithography. So this question is very important for the mains point of view and also for the prelims point of view, the name of the process and also this point that is a serial process and it do not need any mask and it will provide you high resolution. So these points can come in your prelims exam. Now let us see the ion beam lithography process. In this particular lithography process, we use ion instead of the electron beam. So we have seen that the ions are resist is more sensitive to ions than the electron. So we use ion for this purpose. In this process, we have less scattering. Okay, the next type of lithography is X-ray lithography. So I have covered one particular point of resolution that X is equals to K1 lambda upon Na. So this is one type of projection printing. So, so here the X is directly proportional to lambda. If I will decrease wavelength, I can decrease X value. So X is a minimum transferable length. So it will decide my resolution. So the X will be small, then resolution will be high. So in the X-ray beam, I have my wavelength very small. So it will decrease my X value and it will increase my resolution. So, and it also has high aspect ratio. And in this process, we need higher sensitive resist and also brighter X-ray sources needed. So these points are all about the X-ray lithography. And also one particular problem which is called shadow printing problem. So it means instead of our actual window, we have our shadow of the window beside my actual window. So this problem is also present in X-ray beam lithography. So this is all about today's session. If you like the video, please subscribe to the channel. Thank you so much.